Welcome everyone to the part 3 of exploratory data analysis. So let's see the agenda of today's lecture. We will learn about some tools and techniques of EDA, and these techniques include box plots, which are used to visualize the variability or distribution of the data and identify outliers. And these box plots are also very helpful when you want to do statistical analysis. Next, we have scatter plots, which are used to identify patterns and relationships between variables. So let's see what is actually a box plot and how we can do EDA using the box plots. In R, a box plot is a graphical representation of the distribution of a variable. It shows the median, quartiles, and extreme values of the variable and can be used to detect outliers and compare the distributions of different variables or groups. So, how to create a box plot? There are two ways to create a box plot in R. The first one is to use the box plot built-in function, and the second one is to use the ggplot2 package. So the syntax is quite simple. This is the first method in which you just use the box plot keyword, pass the parameter such as dataset and the title. And the second method is about using the ggplot function. So now let's move to our studio to see how we can use box plots. Well, first of all, I will set my working directory. I will say data science T and data science R. And at first, I will read the CSV file with the help of read.csv function. And here I will pass the name of my CSV file. All right. Now let's say head cars. You can see the columns and the rows of your data set. Now, on the very first hand, let's say I use the first method of using the built-in box plot function to create the box plot of engine horsepower. So in order to do that, I will say box plot 1. And inside this variable, I use the box plot function. And here I pass the cars to the frame, and I say take the variable or feature of engine horsepower. All right. And the main, or you can say the title should be box plot of engine horsepower. All right. And here I say box plot 1. Now let's run it. Great. So you can see a pretty box plot here of engine horsepower. And you can see these dots or these points outside the box plot. And these points are the extreme values in the data set. And we call these points outliers. We will study about these outliers in the next outline. So let's talk more about the box plot. The line that you see here in the middle represents the median or the middlemost values of the dataset. And this is the first quartile, and this represents the third quartile. So that is how you can do analysis of your box plot. And you can see that the engine horsepower that is above than 500 are outliers. And we can see that the gap between median and third quartile is more as compared to first quartile. So it means that the data set values are skewed towards the right side. Now let's move forward. All right. Now let's say I want to create a box plot for each of the numerical variable in my car's data set. So first, I will create a variable with the name of known variables, and here I will say names function, and inside that I will pass my dataset And here I will use the sapply function, and I will say take the cars to the set, and the function that should be applied is numeric. All right. Now I will create a loop. I will say for column in num variables. All right. And here I will simply use the box plot function. I will say box plot and take the cars to the set and the column that is in the iteration and main equals to paste. And here I will say box plot of, and here I will pass the column name and xlab equals to column name and the y label equals to values. All right. So you can see a box plot for your last variable, which is price. And this is the box plot for popularity, and you can see some outliers here at this point. And this is the box plot for city MPG that contain a lot of outliers. This one is for highway MPG, and here's the box plot for the number of those, and you can see that the median value is 4. So it means that on average, most of the cars are using 4 number of doors. And this one is for engine cylinders. You can see some cars that even has 0 cylinders. They may be electrical cars, and these cars are using 15 cylinders, so they might be trucks or these kind of cars. So that's how you can create a box plot using the simple box plot function. Now, let's talk about how we can create a box plot using the ggplot2 package. At first, I have to load it. All right. Then I will say box plot3, and here I will say ggplot function. I will pass the data set of cars and then the aesthetic function, and I say take the cars data set variable of engine cylinders on the x-axis and take the cars data set and the column of engine horsepower on the y-axis, and here I will simply use the geom box plot function. Let's just say box plot3 and run it to see the output. Now you can see a pretty box plot for engine cylinders versus engine horsepower. All right. You can see if the engine cylinders are 8, then there is an increase in engine horsepower that is quite obvious. And this is the horsepower for the rest of the engine cylinders on the y-axis. And this is how you can do exploratory data analysis using the box plot on different variables and get insights from the dataset. Now let's get back to slides. Next, we have scatter plots. A scatter plot is a graphical representation of the relationship between two variables. It shows that the values of two variables as a set of points on a two-dimensional coordinate system, with one variable plotted along the x-axis and the other variable plotted along the y-axis. So let's say you plot engine cylinders on the x-axis and you plot the price feature on y-axis and see the relation of engine cylinders and price. Now you might be wondering then how we can create a scatter plot. So to create a scatter plot in R, you can either use the plot function or the ggplot2 package. The very first method is by using the built-in plot function and then passing the parameters such as x-axis variable and the variable for y-axis and some additional parameters. For the customization purpose, the very next method is with the ggplot. You just use the ggplot function and then pass the dataset, aesthetic function, and the geom point parameter. So let's move to our studio to see how it works. All right. So first of all, let's use a simple method. I will just simply say plot1. And here I will use the plot function. And I say take the cars data frame and take the engine cylinders on x-axis and take the cars data frame and take the MSRP for y-axis, and main should be scatter plot between cylinders versus MSRP. And in the last, I say plot 1. All right. So you can see that the price increases as the engine cylinder increase. So this means that the relationship between these two variables is linearly positive. Now let's see the relation of other variables. I say plot 2 and I use the plot function. I say take the cost data set and take the popularity on x-axis and take the cost data set again and take the MSRP on y-axis, and the main should be scatter plot between popularity versus MSRP. And here I say plot 2. All right, so you can see the relation between popularity and price. You can see if the popularity is between these values, then the price is likely to be under 0.5 million. However, there is not much correlation between these two variables. So now let's move forward and use the ggplot2 package and see the relationship between the variables. So at first I will say plot 3. All right, I use the ggplot function and I say take the dataset of cars and take the aesthetic function, and on x-axis it should be cars dataset variable of engine cylinders, and on y-axis I would be saying cars dataset engine horsepower. I want to see what's the relationship between cylinders and engine horsepower. All right, in the last, let's say geom point. Great. Plot 3. Let's just run it. So here's the relation. You can see that with the increase in cylinder, the engine horsepower is increasing. And let's just find out the relation between the engine horsepower and city MPG. Here I will say city MPG. All right. Well, there is not much linear relationship between these two variables. However, you can see that if the engine horsepower is below 250, then the city MPG is most likely to increase. But if the engine horsepower increase, then the city MPG decreases. Now let's get back to slides. So this is the end of today's lecture. end of this outline as well. You have learned how to do the statistical and descriptive analysis using the summary function, using the box plots, scatter plots, histogram, density plots, and by using other functions as well. So I have designed the homework for you. Your homework is to use the box plot to find the distribution of data and use the scatter plot to find the relationship between variables. So here's the link of the dataset. Now good luck, see you next time.